Good morning, friends. Welcome to the Spring Cloud Session 4. Thank you for watching my earlier videos. In this session, we are going to focus on inter-microservice communication, how two microservices communicate in a asynchronous form. Okay, what is meant by asynchronous form is like one microservice calls other microservice. It doesn't wait till the called microservice to respond. Suppose A is calling B, A don't wait till B responds. So this is a very good pattern. I discussed about asynchronous microservice communication when I was explaining in my previous session in RabbitMQ. You can follow uh, that RabbitMQ session to understand why we need asynchronous communication and what are the benefits of it. Okay, this session I won't repeat whatever I said in my previous session. I'm just going to focus on the Kafka. Kafka plays a role of message broker. Essentially, if A is calling B in asynchronous world, they won't directly call. They use one messenger in the middle. They use a broker. Okay, like A calls some broker, and the broker gives that message to B, and once again B gives response to A, and A can like that. Those patterns come. So the simple way to represent is if A is calling B in asynchronous fashion, generally it is achieved efficiently with using a broker in the middle, or we call it a message bus, we call it a broker. So here I'm going to deal with Kafka. Kafka is a very popular messaging bus, very popular messaging system. Few people call it a middleware. So it's nothing but a message bus. So while you are learning a message bus, few of the vocabulary that you need to be comfortable. So I'm going to explain you. And I'm going to explain a Spring Cloud Stream. Okay, Spring Cloud Stream is nothing but a library, an abstraction library on top of message bus. Like when you're writing a JDBC programs, right? You don't write, you don't code against the database. You write against the JDBC specification, right? So today you are using MySQL server, tomorrow you want to use Oracle, then you really need not to change your Java code. That's the similar intention of the Spring Cloud Stream project. Okay, you write the code against the messaging system. Okay, so you write the code abstracted from the what is an underneath messaging system. So that is what Spring Cloud Stream project like. Think it's more analogous to your JDBC code. Okay, like JDBC abstracts the database what you are using. Spring Cloud Stream abstracts the messaging system what they use. There are very popular messaging systems like Kafka, MQ, RabbitMQ. People call it. Okay, I'm not getting the other like IBM MQ. So when you write code, you shouldn't write against each and every implementation. So that is the benefit of using Spring Cloud Stream. Okay, so now let us jump into the few terminologies that you need to know. So when you are saying about Kafka, right? I'm not going to Kafka is a very complex ecosystem, which I'm going to cover in my next sessions when I'm going to explain you more details about Kafka. But just think these things. A producer is an application which is producing messages. That's what a producer produces it. And similarly, consumer is an application consumes the messages. That is what you need to know. While producer producing it and consumer consuming it, there is a man in the middle. He is the broker. Okay, he is a Kafka server, he is a broker. So that is what man in the middle. And the topic is like producer produces to the topic, places it in the topic, and consumer reads from the topic. That is what a topic is. Things like a queue. Few people call it a queue. You can call it a topic. So producer places it in the topic, and consumer reads from the topic. That is the vocabulary which you need to know while you are learning Kafka. uh, I mean the basic Kafka. Then when you are becoming a pro, we obviously there are several things like partitions, okay, leader, follower. There are so many things which I'm not going to discuss. Consumer groups, that we will keep it aside when we are dealing completely with Kafka. Now, Spring Cloud Stream. When you are learning Spring Cloud Stream library, then you need to think these three terminals which you need to know. Binder is nothing but binding is nothing but it's nothing but an interface. It's an interface collection of channel. Okay, so think in this like channel is where you have input and output is where you write. Remember one terminology, output is you write to the Kafka, and input is right you read from the Kafka. you read from the message. These are the interfaces. Output interface is to write and input interface is to read. Remember that that is a channel. A channel will have input and output interfaces. You write to channels. Okay. Binding is nothing but collection of channels. Okay. It's nothing but interface collection of channels. Stream listener is nothing but listens on that channel to read messages. Okay. Stream listener listens on input channel to read message. So all you need to know is channel, which has input and output. Bindings is nothing but a collection of channels, and listeners is nothing but a listener which listens on the out input channel. A listener listens on the input channel. I know this vocabulary even now I get confused a lot, but that is how it is. So you have to learn this vocabulary so that the underneath message bus is abstracted from you. You code against these terms. Okay. Your Java code, what you do is code against this term, then you're underneath Kafka or RabbitMQ, you really need not to bother much. Okay, so now let us jump to whiteboard and I'll explain you my environment so that it's very easy. This entire tutorial I documented in my GitHub repository, Spring Cloud Session-4, inter microservice communication, asynchronous Kafka. If you clone this project, you get your Kafka server, then you cut the Java code, you can run them and stuff. Okay, so let me go to the whiteboard and explain you what do I have. So I have one, let me take the black pen. I have one virtual machine. The reason is I'm using Windows machine. So I have to run Kafka inside a Docker container. Okay. So I felt running it on a Linux machine. I have a Linux machine, which is like CentOS 7, where inside it I have Docker. Inside Docker, I have Kafka. This is, you remember, in this fashion. So this I run inside the Docker Kafka. It's very easy. Then the Kafka has a port, like the message bus. When you have to connect to a message bus, right? You need to, it's a TCP socket. You need to know which port. So I think 9021. Let me check back once. Okay. So the Kafka is running on port 9092. So I have 9092 and another Kafka UI application. It's very easy what is happening with the Kafka. You want to see the UI application. And 9092 is the broker. You send message to 9092 and you read message from 9092. That's a broker. Now we have 9021 is an admin UI. So you have a port 9021 is an admin UI. You can access and view that. Okay, so without admin UI will be like this. If you see my blog, I'm going to bring that up. This is what the admin UI. You will see what is my Kafka server and stuff. Right, you understood, right? I'm running the Kafka server in a Linux container, sorry, in a Docker container inside the Linux operating system. I'm having Windows 10 as my base host. As usual, you guys all know a typical pattern which we follow is like gateway. I'm not going to cover this. You already know Eureka server. We have a registry. If you follow my previous sessions, that's the same thing. You have employee API. Okay. Then you have payroll API. Then you have, these are the two APIs which you need to focus. Now you have report API and there is another API called mail API. Okay, you need to focus these two. So this report API is a producer. It writes to Kafka topic. Okay, producer. Similarly, mail API is a consumer. It is a consumer. Mail API is a consumer. If I want to give you a simple overview, so someone asks, give the employee report. What is employee report means? What is his employee ID? If you give employee ID, the employee report will contain employee name and what is his salary and what is his salary. Those are the two information, employee name and employee salary. So employee name comes from employee API, payroll information like salary information comes from payroll API. So these report API is going to call these as well. These are like sync. It calls these two calls. So it waits. So it calls employee API and gets employee information. It calls payroll API and gets payroll information. But when it has to send that information via email to users, it has to send via email and it has to display in user on web interface also. So what we will do is we will use asynchronous email. Like if it is fine, you get in half an hour or 10 minutes after that, your email that you're perfectly fine, an SMS after an hour or something like that. So that is like asynchronous communication. I really need not to wait till the mail is sent to the user, right? So there we use async communication. So report API produces it async form, and then mail API reads it. Okay. There is a non-blocking IO concept here, which I'm not going to cover, but when I cover non-blocking IO, I'll cover that. Okay. Remember that there is something like non-blocking IO. Okay, that's it. So asynchronous means A doesn't wait till B responds. Report API just says that send email with employee details to him and it comes back. It doesn't wait till the mail API responds. Okay, so that is what a typical like from the browser. From browser, someone asks get a report of employee with 100. It calls report API. Report API is going to call this and stuff. Or let me not to be very fast. So someone calls a gateway to give a report of an employee 100, which calls report API, where report API calls employee API and payroll API in synchronous fashion and gets the details and give it to the Kafka to give it to the mail API, and the mail API sends an email. So these two are asynchronous. Our primary focus is on this part. Okay. So if you follow my RabbitMQ asynchronous inter microservice communication asynchronous with RabbitMQ, you will understand this. This is very trivial. So there I covered in depth all these things a little bit more. Here I want to focus how easy you write a Java code which abstracts from the underneath messaging system. Either you don't code against Kafka, you don't code against RabbitMQ. That is what I want to focus here. So now you understood, right? Let us jump into the code. Let us play with the tutorial. Now the entire tutorial is documented in this GitHub repository clone. I cloned it in the folder called Kafka. Then my first step, okay, before doing that, I want to bring my Kafka server up, right? So as I said, I'm running, as I said, right, I'm running Kafka in a virtual machine. I use Vagrant to bring the virtual machine up. Vagrant is like some orchestration tool, okay, to spin your virtual machine stuff, which I found very easy to start and stop VM. Just think like Vagrant. After you check out my code, you just do Vagrant up. It will bring the virtual machine up, install Docker, do so many things. Okay, which is abstracted. I already have, and I'll take SSH. Vagrant SSH takes SSH to the server. Okay, then I'll switch to root user. Okay, I'm on the Kafka server now. I switch it to the root user. There is a folder called Vagrant, which has all the files, like the GitHub repo, which I cloned, right? I have all the files here. So it's nothing but your file system is mounted here, nothing more. You cloned into Windows machine, that Windows machine files are coming here onto the Linux machine. So quick, if you want to see cat Vagrant, if you want to see the Vagrant file, it's nothing. It's very server. What I'll say is I'm asking 9021 and 9092 ports. Those are the two ports. 9092 is a broker port and 9021 is an admin port to be exposed to my Windows. So that from browser, I can show you very easily. Okay. So I'm exposing that ports. That is what the Vagrant file is. Now, important thing is like you have Docker compose file. I'll run it in a Docker, right? So if you want to see Docker compose file, this is the Docker file which brings the entire Kafka servers and its ecosystem. I'm not going to delve this. I got it from Confluent. We are going to use Confluent Kafka. So it's like they already dockerized it. All you need to do is simple thing. You just run this one command, docker -compose up -d. So this starts the Kafka container in a background mode. -d means run it in a daemon. Daemon means not attached to any terminal. Even you close the terminal, the process runs in a background. So docker compose up, it downloads the images, everything, brings the Kafka server up. This is very simple way to start Kafka server. So docker compose up -d, that's it. The Kafka server comes up. I already have a Docker Kafka server. If you want to see what I'm having, you can see like there are several things. It is gkeeper. I'm not going to do all those. Simple thing is docker compose up -d brings the Kafka server up. Now we have a Kafka server up. So if you want to see the Kafka server UI, you can go and access 9021. The port is like 9021/clusters. It show you the Kafka server. Like this is the Kafka server. Okay. Now the topics. This is a topic queue email where we are going to write message and we are going to read from that. Okay. So let me see, is there any messages on this? So, and currently there are no messages because we didn't bring any environment up. So that's hot about the Kafka server, right? I'm running Kafka server in a Linux machine on a Docker. Docker compose up -d, runs it in a daemon, then access the UI. You are all set. The Kafka server is set. The next thing is like our standard thing. After you do the code, then you do maven clean install. You build the code because I don't have artifacts in the repository. Like I don't check in the binaries in the GitHub. You just need to build it. Now build the code. The first step, what is like, we will bring the registry up. So we'll bring this component up. So you know what is the role of a registry in a microservice landscape, right? So I'm bringing the microservice registry up. Once the registry started, then I'm going to start the employee API. Okay, I'm going to start the payroll API. Okay, now I am going to start the report API, which is going to call both employee and payroll API as well, right? So the report API is also going to call. I'm starting my report API. Pay attention to report API. Report API calls employee API and also payroll API and also mail client, but it won't directly call it. It calls Kafka. It doesn't know about anything about mail client. Okay, report API calls Kafka. So it has to bind to Kafka also. So that is what you need to understand. So the report API is up. Similarly, the mail client, which reads from the Kafka topic. It doesn't care about the ecosystem. So the mail client is up. Then what we have is the gateway, the front door or the edge server, some people call. Okay, so let's bring the gateway as well. We got everything up. So let's take some time for the environment to settle. In the meanwhile, I'll go and explain you the code. Okay, so here I'll do a just brief about the code. If you want to go in depth, watch my earlier session with RabbitMQ, which in detail I explained. So simple thing, a report API controller, right? This is a class which is going to get the messages, right? So report API controller, where employee pass the report API to fetch the employee details, like employee report, and an email also needs to be generated. Simple REST controller, employee ID you are casting. Pay attention to this annotation, enable binding. So make this listener bind to a Kafka channels, okay, or you can say bind to these channels. Okay, channel is where you write and read, right? So the channel what you write is an output channel. So bind to this channel. So the channel is a predefined class I used. So you can use your custom channels also. So channel is nothing but interface which with output and input. That's all. So send to means write. Okay. So, and I auto wired. Then look at this code. This is very trivial, you know, right? The first step is like when someone pass employee ID, it gets employee details from employee API, payroll details from payroll API, then it creates a new employee object and sends. This is the magic. Output.send and message builder with payload, it's serializing it and sending it to Kafka, because Kafka follows its own internal protocol. We really don't know. MQ follows its own internal messaging protocol, which is very abstracted from us. So all you need to do is you need to call Kafka with send method, send messages to Kafka, send messages to RabbitMQ and message builder. And this is what our employee object, we are serializing it and sending it. This is what sending it to Kafka. If you see the application.yaml, the cool thing is here. If you watch the RabbitMQ and this, there is absolutely same. With only we are saying that Kafka is a binder. We are binding it to the Kafka instead of Rabbit, and the Kafka is running on this host and with 9092, the same port, right? 9092 is the broker port. We are writing it to this. This is what the producer. Now we saw report API as a producer using send to writing it to the Kafka. Now let us read, okay? So, you know, mail client is a reading application, right? Let me close all. Mail client such main resources. The mail client, this is what we are saying. The mail client application, I'm calling it's an email API, and it is using, and it is listening to topic. And this is what the Kafka server and Kafka port. Only this change. This is the only change between Kafka and RabbitMQ. The code rest is same. You don't bother about the code. Okay. When you are using Kafka or RabbitMQ, this is the only place you will say, instead of Kafka RabbitMQ binder, you'll say Kafka is the binder. Bind to Kafka, not to RabbitMQ. That is the only change you do. So as usual, you know, if you watch my previous video, I just explained in depth. This is what I'll say. I'm using Kafka stream dependency, cloud streams, right? We are using cloud stream. So you are saying Kafka is a dependency. This is a one dependency which you need to add, and after that you need to have a client. So enable, this is the client application which is reading. So the read happens on input, right? So this is what input. A stream listener listens on the channel, input channel. When a message comes, it gets invoked. This received email gets invoked, and email object gets serialized, and you're going to see the value. So understand, mail client is the consumer, report API is the producer. That's the only thing. Report API is the producer and mail client is a consumer, and Kafka we are having. So now everything is up. Now let us try to send a call like this, get the report. Now let me see and get the report. So what happens is, now it is calls mail API, it calls, sorry, it won't call mail API. Now it calls employee API, it calls payroll API, then it gets messages, then give it to the produce Kafka, then mail API gets invoked and sends email. So this is what happening when calls to in sync, and this is an async communication. So if you go back and see the report API, right? So see report API connected to Kafka server, and it produced one message. And mail API, you can see here, it got one message. Okay, it got one message saying that it received a message, Alex, and it sends email. But I don't have that code. I just prints it. And so the mail client reads and displays. If you want to see what message it has sent, if you can see it in Kafka also. So topics, queue, sorry, topics. This is a topic, and messages. So currently there is no message. I'll just quickly send one. I started. Let me send one more message by calling the API. If you see, the message got created and here it should show clearly. No new messages. Somehow I'm unable to show you within the Kafka admin interface. What is the message? Great. You can see here one message we got, right? So just now the message that got, it has name, value. So this is what value ID 100 with Alex and 6,500. Let us call what's that? Tom salary send and see Tom, his salary is 65K or I don't know. Let me, his salary is 90K and his ID is 101. So I just showed you that you can watch messages in the control center. They call it a Kafka admin UI as well. That is what I want to show you. So what essentially happened is producer produces it, consumer consumed it, and we display. Now, brain for food, what happens if I increase producers? What happens if I increase consumers? I'll show you. So let me increase the consumer here, like what is the consumer mail client? I'll run one more mail client, and so this the easy way to run mail client. If you go to my documentation, Java jar, I do remember the command, but just I want to test my documentation. So if you want to run one more instance of mail client, you can do like this. Okay. So the one more instance of mail client came, it listened to topic, it joined, blah, blah, blah. So now let us send whether both the consumer get message. No, this time the first one got it, received Tom. Now, even the second time also this got. Ideally, both of them are in the same consumer group. Both of them should get in a round robin fashion. Somehow it's not working. I couldn't demo that. Anyhow, I'm not touching the consumer groups. So somehow we got the second client. It is lying ideal. Only the messages are going to the first client. I think I didn't set the partitions right and stuff. Okay, we'll fix that, or as a food for you, you can understand that. So yeah, it clearly shows the partition assigns are 0. It won't get any messages. It tries ideal. We'll deal that. I'll explain you when I'm explaining Kafka. So with that, I'm done. This entire Kafka, then producer, consumer, everything, you can get it up with my GitHub repository. You need not to download any other software. Very simple to follow. Anything did I missed? Let me go back to my slide once. I think that's it. So I showed you the code, I showed you the configurations, I showed you how to run. Yeah, do remember in mind, we use Spring Cloud Stream to do abstraction, and that abstraction means what is the underneath messaging system we are using. So whether it can be RabbitMQ, or whether it can be the Kafka. So thank you for watching my video. So